follows along regular long division. So if you think back to your steps, and again, I hope this comes back to you as we work through it from last year. But if you remember the steps for regular old long division, then you will not have a problem with polynomial long division. So what I'm going to do is I'm going to set up 123. I'm going to set up a regular old long division problem over here. And then to the side, I'm going to work a polynomial long division so you can see how the steps are the same as we go. Now, polynomials can be written different ways as you divide. Okay, it could already be set up like this for you in the little house. Or maybe this could also, and I'm going to use this one as an example, and then I'll show you the polynomials. I could write this as 123 divided by 5 or 123 over 5. Just so you know, if you see any of those, the number that follows the division sign is what goes outside of the little house, right? All right. One other little important thing to mention is placeholders. Do you guys remember what placeholders are?
Yeah.
If I have something like 3x to the 4th plus 6x squared minus 5x plus 2, I need to make sure that I have every single power from the highest down. So I start with 4 and I'm missing what? 3. So, exactly. So I do 3x to the 4th plus 0x cubed plus 6x squared minus 5x plus 2. No, this is just the setup of the lesson. All right, so let me give you a problem. And we'll set it up. I guess I need to do this on a separate page. I'm going to take my 5 into 123, and let's do the easiest way, I think, to teach polynomial long division. It's getting cold in here now.
Oh, yeah. Don't get cold now. It's good cold now.
All right, so the first thing you want to do as you set up is to check for placeholders to see if you need any, both inside and outside. So do you need any in this particular example? Not in this one, right? All right, so I want you to look at the one with the 5 here and tell me if you were dividing that, what is the very first thing that you would do? First two numbers, and you do what? And you're right, divide into 12. But what question, if you're explaining this to somebody who has never, ever, ever done long division? Sorry, I didn't mean to. What number do you multiply 5 by to get to 12, right? Or as close to 12 as you can get, and you get 2. And it goes right here above it, right? All right. Well, I'm going to stop at that step, and I'm going to come over here, and I'm going to do the same thing with the polynomial, okay? The key here is we're using first terms only. So look at 3x and look at 3x cubed. What can I multiply 3x by to get 3x cubed? 1x squared, right? Now, I'm going to keep my columns lined up. Okay, so everything in a vertical column above the 3x cubed is going to be powers of 3. Anything vertically above and below the 5x squared is going to be powers of 2, and so on. So I'm going to put the 1x squared here. Does that make sense, everybody? All right, back to the easy example with the 5. What do you do once you put the 2 up top?
Subtract 10.
Well, but what is 10? Where'd you get 10? 5 times 2, right? You multiply these two things together and write it under here, right? I'm going to do the same thing. I'm going to multiply, but when I multiply, be very careful because I have to multiply to everything out here. So what is 1x squared times 3x? 3x cubed. And what is 1x squared times 2? plus 2x squared. Okay? Go back to the 5 example. What do? You got to subtract, right? Well, I get 2. If I subtract over here, again, I need to subtract everything. Okay? So if you'd like to change everything, you can do that. So this would really be, keep this one the same, change this, but change every sign inside.
So would it be, okay, so you just left it as subtraction and you just subtracted everything?
You could, but you'd have to do 5x squared minus 2x squared. You'd have to remember that but yes, you could. And if it helps you to think about it like this, 3x cubed plus 5x squared minus, and this is kind of, we've always done them beside each other horizontally. If it helps you to see it that way, you can write it that way too. Whatever helps you the most. All right, so when I subtract these, tell me what I get. The first one cancels, and the first one should always cancel or else you've done something wrong. Okay, so those cancel. 5x squared and negative 2x squared gives me, okay, back to the example over on the side. What do you do?
Bring 3 down.
Mm-hmm. Bring down the 3. So bring down 8x. Now the whole process starts all over again. What do you multiply 5 by? This time it's to get 23. 4.
Wow.
Okay, so same thing here. What do you multiply 3x by? Only look at the first terms when you're trying to find that to get 3x squared. X, right? Multiply around. So x times 3x is, and x times 2, but I'm subtracting all this.
Yeah, we did it kind of differently.
There's not another way to do long division. Now y'all might have done synthetic division, and we're going to do that today, but it wouldn't work with this one.
What is synthetic division?
When you put a number outside and then you put, so this will be a number, and then you put them all here and you drop down and multiply and divide, multiply. And that's fine.
This was the harder one to do.
Right. This is the one you learn first, and then we show you synthetic. Because synthetic only works in certain circumstances. But the circumstances it does work in, it's quick. Okay. All right. So now I am going to subtract. So we'll do this one instead of changing all the signs. We'll just do this one as 3x squared minus 3x squared cancels. 8x minus 2x minus 2x.
What?
6, I'm sorry. I apologize. Oh my goodness. Okay, yes, I was dividing. Okay, so now what's the next step? What do I do now? Bring down the 7. Process starts all over again. You can, if you really work through a couple long division, you can't help but get them because it's so repetitive.
You didn't subtract that 20.
Yeah, you skipped.
I know. I didn't skip. I'm going to finish that one in a minute once I get to the last step here. I didn't forget. I got it. What do you multiply 3x by to get 6x? 2. Multiply around. 2 times 3x is? And 2 times 2 is?
4.
Okay.
Nah, I said 2 times 3 is 6.
We already did that.
All right. I'm going to subtract here. And here's where we need to look at how we're going to wrap this problem up. 6x's cancel as they should. If your first terms don't cancel out, something has gone wrong. What is 7 minus 4? 3. What is 3? A remainder, okay? I'm going to come back over here and finish this problem. Oh, the remainder's the same. I could do that again if I wanted to. Okay. That's exactly right. So what we do is we write it as a fraction. Over here, I could write this as 24 3/5. Okay? We're not going to just put R3. Like everybody always wants to do R3, just put R3. So what we do is we take the remainder and we put it over what we divided by. Okay, so we would say, since we're polynomials here, we're going to say plus 3 over 3x plus 2. So when you divide these two, you get x squared plus x plus 2 plus 3 over 3x plus 2. And I know you don't see the connection right just yet in the zeros of the polynomials and everything else that we've been finding, but you will.
If you have put like 5 to right about, okay, 30 back, we can hold on.
Yes, because the n number is a factor of 5. Let's do one more together, and I'll be done. I don't want to I want to spend a whole day on polynomial long division because everybody forgets it. Because once you learn synthetic, that's all you want to do. And we do focus a lot on synthetic. Once we learn synthetic, we do a lot with synthetic. And so then you tend to forget about long division. So I want to spend some time talking about long division. Let's do I'm going to help you set it up. And then we'll work through it. What goes outside, what goes inside? And what do you notice this different about? All right, the one on the top goes on the inside. So outside I have 2x squared plus x plus 1.
Yeah.
Okay? Tell me what goes on the inside. That's exactly right. That's what I wanted you to see. 2x to the 4th minus x cubed. I'm missing x squared, and I'm missing x. It's a lot of placeholders.
Hey, yo, give me the ox. That's it.
I like that. That's it.
Oh, Lord. All right, give me first step. Tell me what I do. That's your first step?
You multiply 2 times 2.
It's x squared, exactly. Keep it in the x squared column. All the x squareds are going to go in the same column. If I didn't have that placeholder, I wouldn't have a squared column. Good thing I put it there.
What do you mean?
Wait, what is that?
See, I put 0x squared in, so that gave me an x squared column. What?
So if we was to backtrack, we'll have to something about it.
All right, multiply around.
5, 7, 8, 2, 6,
So that'd be 32
Mm-hmm.
plus x3
Mm-hmm.
plus x squared.
Is anybody lost?
No. Right.
I like teaching this because this is one of those things that looks really complicated when you put it up here. But once you get it, it's really not a hard concept. All right, let's subtract. Do the first two cancel out?
Yeah.
Yes, they do, as they should. What is negative x cubed minus x cubed?
Negative 2x cubed.
Yay. 0x squared minus x squared.
Negative 0.
0x squared minus x squared would be negative x squared. Minus x squared. If it helps you to change all the signs, change all the signs. All right, bring down your next term and start all over again. Wait. Sure? All right, what do you multiply 2x squared by to get negative 2x cubed? Close. Negative x. Negative x. So when I multiply through here, I need to multiply by a negative every time, okay? So I got negative 2x cubed, negative x squared, and negative x.
But they all turn.
That can't possibly cancel out. I know, 'cause it's minus
Ooh, what happens? What's negative x squared minus negative x squared?
It's basically negative square plus.
Which is,
Which is nothing.
what's 0x minus negative x?
It's x squared. No.
It's x. Don't let it throw you. Now look.
That's what made it.
Exactly. Why, Silas? There is nothing that you can multiply a squared term by to get an x.
There's nothing at all.
So that is your remainder. That's how you know you're done, okay? So I know I'm done whenever I get to the point that I can't multiply the outside by anything to get what's left anymore, right? So this is my remainder. So my answer is x squared minus x plus what? X minus 2 over. Tell me what you think.